Again, there are 4 number of links. Okay, now the link OO1 is fixed link, link OA and link O1B are of equal length, and link AB. Okay, in this way there are 4 links. Now here there is a bar PQ, which is rigidly attached to the link AB, and P is the midpoint of link AB. Now, what happens when the mechanism is displaced? See, the new position of mechanism is given here, A dash P dash. When the mechanism is displaced, the point Q on the rod traces an approximate state line. Point Q on the mechanism traces an approximate state line. It's like this. Approximate means, okay. See, now this is a very simple mechanism. PQ is a rigid bar or rigidly attached to this AB. Means you have a welded part right at the end. Now it is welded at the P, and P is the midpoint of AB. When the mechanism is displaced, what happens? Like pendulum, this bar also displaces. Okay, rigidly attached. That's why see the position dotted line, and Q traces an approximate state. Now this is a very simple mechanism. I'll have to only note down. Next mechanism is a robot mechanism, and draw figure. Don't write description, okay? Let draw figure. Okay, now see the next one is grasshopper mechanism. Next mechanism is your grasshopper mechanism. Before that, see this modifies Koch-Russell mechanism, because the grasshopper mechanism is a modification of Koch-Russell mechanism. Okay. Now see, this is a very simple mechanism, Koch-Russell mechanism. Now see here in this mechanism also there are 4 links are there. Now link fixed link is at O. Now link OA, okay. Then link AP and a slider. Slider is one of the link which guide inside the slide inside the guide. Okay. Now here, if you observe this mechanism, a point is a constant to move along a circular path. Okay, or if you change the position of the A, it traces an ellipse. Means it is similar to your elliptical triangle. Okay, means P and Q. Now this is the Q. Q and P slides along a respective path, and that paths are horizontal and vertical. Okay, now P slide along the horizontal path and Q slide along the vertical path. Okay, now in that case, if in the figure A traces an ellipse, that time AP is a minor axis and AQ is your major axis. Okay, now but the mechanism is that suppose A rotate in a circular path. Suppose the A rotate in a circular path, the Q is a point on the extension of link AP traces an approximate state line, not exact state line. Now the mechanism is that when the A rotate in a circular path, Q is a point on extension of link AP traces an approximate straight line if OA is equal to, now there is a ratio of, or the length of the OA is fixed here. OA is equal to AP square upon AQ. Okay, means you have to say this ratio. OA is equal to, you have to maintain the length of OA is equal to AP square upon AQ. Okay, now see here Q is extension point on link AP. Now this is the ratio. OA is equal to AP square into AQ. Okay, now this is the Scott-Russell mechanism. Don't draw this mechanism. Okay, now if you see here, grasshopper mechanism, see, this is the modification of your cross-Russell mechanism. Okay, in that case also there are four links. Link O and O1 are fixed links. Okay, and link OA, which oscillate at an angle AO-A1, and the link AP, and next link is your O1P. Suppose this is the first link, I will mark here. This is the second link, this is the third link, and this is the fourth. Okay, now AQ is not a link. Now see here, this is the Q. AQ is not a link. Okay, now Q is the point on extension of AP. Now how it works here, OA oscillate at an angle AOA1. When the OA oscillate, what happen? The P traces an arc. Now see here, this is arc. P traces an arc whose center is O1. Whose center is O1 and its radius is O1P. And at the same time, the point Q on the extension of AP traces an approximate straight line Q dash. So this is Q dash. How it works? Grasshopper mechanism. When OA oscillate at an angle AO-A1, the point P traces an curve or arc whose radius is O1P. At the same time, Q is the point on extension of AP traces an approximate straight line if OA is equal to, again, the radius of this oscillating link OA or link number 2 is equal to AP square upon AQ. Okay, now this ratio is very important. When you make a mini project of this grasshopper mechanism, you have to take down the distance of OA is equal to AP square upon AQ. Got it, all of you?
Yes, sir.
Now this is very important mechanism as per your exam point of view. Grasshopper mechanism. All of you draw this figure. Don't write description. Write down the heading grasshopper mechanism. Draw this figure and write down the length of OA is equal to AP square upon AQ. Okay.
Yes, sir, done.
Yes, sir, done.
Now here is some of the animation. Now see, this is the one of the mechanism which is known as a pentagram. All of you see this video. Or it traces the figure on in large scale. See here. Okay, here is the pointer and here is the pen. Now here is the figure. You have to draw this figure on a large scale by using this pentagram. You can make a pentagram in mini project also. Okay. Now this is the point which traces an figure, and this is the enlarged scale figure. Got it, all of you?
Yes, sir.
Yes, sir.
Now here the next one. Now here the peculiar mechanism. Again, it is a 8-link mechanism. Okay, here this is the link 1, 1, 2, 3, 4, 5, 6, 7, and 8. Now 8 number link is fixed. The distance of this color here, gray color and this black color, length of both are same. Then red color length are same, green color length are same, blue color length are same. Okay. Now here this is the point B, which traces an exact state line. Now this peculiar mechanism is a exact state line generating mechanism. Okay, so here how it is located on the base. Now there are pin joints because there is a relative motion between the link takes place. Here यहाँ पे अगर fix करेंगे तो there is no relative motion between them. When you make a mechanism, okay, you have to take care of this. When the two links are joined together, there is a relative motion between them. That's why you have to join it by using a pin. This is the peculiar mechanism. Now next mechanism कौन सा था हमारा Hertz mechanism. Again it is a state line generating mechanism, exact state line generating. Now in Hertz mechanism, how many links? Anyone?
6 links.
There are 6 number of links in Hertz mechanism. Okay. Here these are the cross links. यहाँ पे link है. Now this is the fixed link. यहाँ पे रहेगा. Now this is the CF, ED, CD, then EF. Okay. Now B point is here, and it traces an exact state line. Again, it is an exact state line generating mechanism, Hertz mechanism. Now next is Robert mechanism. Here, now this bar is rigidly attached to this AB. Okay, horizontally at the midpoint, and it traces an approximate state line. Here, it is not exact state line. Robert's mechanism. The grasshopper mechanism. Yeah, this is the grasshopper mechanism. Okay, now this link is isolate at an angle AO A1. Now here is the point P. Here, this is the point P. Traces an arc. Its center or radius is this much. Okay, and on the extension of link AP, suppose this is the link AP, there is a Q point which traces a straight line. Now see the TB chip mechanism. Again, it is approximate straight line generating mechanism. Now in that mechanism, there are 4 links. यहाँ पे link fix है. Red color links are, these are the 2 links are of equal length, and yellow color is a 1 link. Now at the center of or midpoint of yellow link, the point traces an approximate straight line. Okay. When the mechanism is at extreme position, here, this is the extreme position of this mechanism towards the left hand side. See, all the points are on a vertical line, and the ratio of the links are known here. Yellow link is of 1 unit, suppose 1 centimeter. That time this distance between the fixed link is your 2, and red color links are of length 2.5 centimeter. Okay, this 1 to 2 to 2.5. You have to maintain this ratio. Okay, or one more mechanism is here, Watt's mechanism. Here, this is the Watt's mechanism. Approximate straight line generating mechanism. Okay, यहाँ पे horizontal link है. These are the 2 horizontal links, and this is the vertical link. Okay, and these 2 horizontal links are pivoted here, and any point on this link, vertical link is traces an approximate straight line, but there is a ratio. We have to maintain that ratio, then it traces an approximate straight line like this. Okay, got it all of you?
Yes, sir.
समझ में आ रहा है ना? Here we finish the straight line generating mechanisms. In straight line generating mechanism, there are 3. Our first one is a pantograph. It is not straight line generating mechanism. Again, there is a question in university question paper of 4 or 5 marks. What is pantograph or extend pantograph? Or the remaining mechanisms are your Hertz mechanism is again very important mechanism. Hertz mechanism is your exact straight line generating mechanism. Then in approximate straight line generating mechanism, grasshopper mechanism and TB chip mechanism, these 2 are very important as per your exam point of view. Okay, now we will start the next special mechanism is your next one is your steering gear mechanism. Steering gear mechanism. Next one, write down all of them. Note down this point. Steering gear mechanism. Again, in university question paper, there is a question of 5 marks. Derive an equation of correct steering gear mechanism. When you design a mechanism for any vehicle, steering mechanism for any vehicle or four-wheeler mechanism, four-wheel vehicle. Now, it is very important to maintain this or satisfy this condition. Okay, the steering gear mechanism condition. Okay, now tell me what is the role of steering?
To control the front wheels,
Give the direction
to the vehicle.
Turning the vehicle.
It is used to turn the vehicle or to
The direction
change
of the vehicle.
correct, to change the direction of vehicle or to change the direction of wheel or move the vehicle into the desired path. Steering gear ka or steering is used to change the direction of wheel. When the direction of wheel get changed, automatically direction of vehicle get changed. Okay, and to move the vehicle into the desired path. Okay, but there is a condition of motion between wheel and road surface. Now, anyone tell me what is the motion between wheel and road surface? Wheel and road surface, or which type of motion takes place? Suppose your road surface is fixed link and another is your wheel. Which type of motion takes place between them?
Line contact.
Not motion. Tell me motion between them.
Rolling.
Correct. There is a
Random
rolling.
motion.
Okay, the motion between the wheel and road surface is a pure rolling motion to prevent the skidding of vehicle or wear of the vehicle. Wheel tire. Okay, to prevent the skidding and wear of the wheel tire. But when it is possible, to prevent the skidding of the wheel tire. Now again there is a one more condition, or tell me the contact between the road surface and wheel tire. Road surface and wheel tire. What is the contact?
Line contact.
Or if you see the wheels of your two-wheeler vehicle or four-wheeler vehicle, these are not exact state. Okay, it is a curvature. Okay, means the contact between them is not a straight line. It is a concentric circular arc.
Point
Not
contact.
point. It is concentric circular arc. The contact between the wheel and the road surface is concentric circular arc while taking a turn. When this contact or this concentric circular arc is the contact between the two wheel and road surface, then you will get the pure rolling motion. Okay, and it prevents the skidding of the vehicle. अगर हमने टायर देखा सपोज टू व्हीलर का, नाउ इट इज अ सर्कुलर आर्क रहता है वो, नॉट इट इज नॉट अ फ्लैट. ओके, you don't need any way. Why it is a circular or arc? Because to prevent the skidding of the vehicle, and the contact between the wheel and road surface is your concentric circular arc. Okay. Now consider here the four-wheel vehicle. Suppose we will consider here the four-wheel vehicle. Okay, now these are the front wheels, or you can say it is a front axle. This is the front axle. Consider the four-wheeler vehicle, and this is the rear axle. Okay. Now these are the front wheels, E and F. E and F are the front wheels which are mounted on the stub axle. We can say this is a stub axle. So A and B. Stub axle means it is a short axle, okay, which is pivoted to this front axle. Okay, why it is short axle? Because it is pin joint at the A and B to the front axle. While the vehicle taking a turn towards the left or right, these front wheels are attached to the steering. Okay, if you want to take a turn towards the right, that time you have to turn the steering. Only the stub axle gets turned about the A and B. Only stub axle get turned about the A and B. Now the stub axle is a very short axle. Okay, and C and D are the rear wheels, are mounted on the rear axle, which is mounted on the rear axle. Okay, and this rear wheels are follow the same path of front wheel. Got it, all of you?
Yes, sir.
Yes.
Now suppose consider the vehicle taking towards right turn. Okay, happy right turn लिया है. Now the stub axle BF and AE turn towards the right hand side, and the new position of wheel, front wheels are यहाँ पे F dash, or this wheel F wheel turn at an angle theta. At the same time, this E wheel turn at an angle phi. This angle is your phi. E dash. While the vehicle taking a turn towards the right, wheel F changes its position at F dash at an angle theta, and E at a E dash. Okay, now tell me which turning angle is greater, theta or phi?
Theta.
Theta.
Vehicle taking a turn towards the right or left, the inner wheel turning angle is always greater than outer wheel turning angle. It take a right turn means F is your inner wheel. If you take a left turn, E is your inner wheel. Okay. While taking a turn, towards right or left, the turning angle of inner wheel is always greater than outer wheel. Now, what is the condition of cadet steering gear mechanism? While taking a turn, vehicle taking a turn, the ICR of front wheel lie or intersect. ICR of front wheel intersect on the axis of rear wheel. Suppose this is the axis of rear wheel. Okay. At that time, ICR of both the front wheels intersect or lie on the axis of rear wheel. Okay. What is the condition of correct steering gear mechanism? While vehicle taking turn towards left or right, ICR of the both the front wheels, turning wheels, lie on the axis of rear wheel. Okay, समझ में आ रहा है?
Yes.
Okay. Now you will get the pure rolling motion and it prevents the skidding of the vehicle. But you have to find out the condition of that correct steering gear mechanism. Now tell me this angle is how much? This one angle कितना रहेगा? Phi ना? It is opposite angle, and this angle is your theta. Correct? Okay, now you will get here two right angle triangles. So you have to consider the two right angle triangles. Triangle IDB. Suppose I will consider here triangle IDB. IDB. Okay, and tell me the cot. Consider the triangle IDB and tell me cot theta is equal. Cot theta. Cot theta is equal to what means which side? Ratio of which side? Give me answer. Cot theta क्या आएगा यहाँ पे? Cot
di
theta is equal to
upon
ratio
bd.
what?
Di upon bd.
Di upon BD or ID upon BD. Cot means adjacent divided by opposite. Tan means opposite upon adjacent. Correct? ID upon BD. Okay? ID upon BD. Now here the distance between the front and rear wheel is your L. Consider distance between these two rear wheel and front wheel or axle is L, and you can say wheel base यहाँ पे CD यहाँ पे है. Now you have to consider this C and this is D. Yeah, GH. Now rear wheels you have to change the notation GH. Okay, and you have to consider the triangle IDB. Okay, now this CD distance or wheelbase you can say it is a B, small b. Okay, now you have to consider here triangle IDB. Find out the cot theta means you will get the ID upon BD. If you see figure ID upon BD, BD is your distance between the two front and rear axle. Means you will get here ID upon L. Now this is the first equation. Similarly, you have to consider the second triangle is your ICA. Again, the next triangle is your ICA. And you have to find out here cot phi is equal to. Okay, cot phi. Cot phi is equal to anyone? Consider triangle
Ci
I.
upon is
Correct.
AC.
CI upon SC.
Correct. Means IC upon AC. Or you have to write down IC upon AC is equal to again the distance between front and rear axle L. IC upon L. This is the small L second equation. Okay. Now you have to do your equation 1 minus 2 or subtract the equation 1 or 2 minus 1. Subtract the equation 1 from 2. 2 minus 1. What you will get here? Anyone? क्या आएगा यहाँ पे? Cot theta minus cot phi minus cot theta is equal to क्या आएगा?
B by L.
Correct. Theta is equal to IC minus ID upon L. Correct. IC minus ID upon L. Now what is this IC minus ID? Anyone tell me from figure?
B.
See the distance IC is here. Minus ID means you will get the B. Means you here B by L. Okay, means the condition of correct steering gear mechanism is cot phi minus cot theta is equal to B by L. Okay, B is a wheelbase. L is a distance between the front and rear axle. Means when you design the steering gear mechanism, you have to design it such that this angle theta and phi are adjusted automatically while taking a turn, and the ICR of both the front wheels lie on the axis of rear wheel. Okay, the axis of rear wheel. Got it, all of you?
Yes, sir.
Okay, now this is very simple derivation. It is asked for 5 marks. Derive an equation of condition of correct steering gear mechanism. In description, you have to write down the small part. Means suppose the steering is used to change the direction of wheel and to move the vehicle into the desired path. Okay. Now the motion between the wheel and road surface is pure rolling motion to prevent the wear and skidding of the vehicle. For getting the pure rolling motion, the contact between wheel and road surface is pure concentric circular arc. Okay, now I have to write down the description of this figure. Consider the four-wheel vehicle of front wheels A and F are mounted on the stub axle AE and BF. Okay, then the rear wheels G and H are mounted on the rear axle CD. Consider the vehicle taking a turn towards the right. The inner wheel F turn at an angle theta and outer wheel E turn at an angle phi. Okay, but the condition of correct steering gear mechanism is that while the vehicle taking a turn towards the right or left, ICR of both the front wheel or turning wheel lie on the axis of rear wheel. Now consider figure or consider triangle. First angle IDB, find out the cot theta. Consider second triangle ICA, find out the cos phi. Now subtract the equation 1 from equation 2, you will get the condition cot phi minus cot theta is equal to B by M. Got it? According to the weightage, you have to write down the description also. Okay, description is here. Now, see, this is the figure. All of you draw this figure and write down the derivation. Okay, यहाँ पे this is the description is given here. Now start. Okay, 1 minute. I will send attendance. Okay. Okay, so last आवाज आ रहा है क्या?
हमारे सर आवाज
कल्पेश, can you hear me? Hello, hello, hello.